First, we need a 3D car model. BlenderKit has several 3D assets available for free. Let's head to BlenderKit.com and download BlenderKit add-on. Let's head back to Blender and under Edit, Preferences, Add-ons, click Install and select the downloaded BlenderKit add-on zip file. Then click on Install Add-on button. Also ensure that the checkbox next to Add-on is enabled. The downloaded assets are stored in the folder configured here. Press N to open the N panel and click on BlenderKit tab. Under Search Filters, check on Free First. Type Cars in the search bar and select the 3D car model. Here we have selected Ferrari 812 Superfast. Thank you Jayrenn Reeve and the BlenderKit team. Let's head to Render Properties. Under Performance, change the tile size to 512 as I'm using a GPU. Under Simplify, change the texture limit to 512 resolution for faster response for both viewport and render. Also, the viewport render sampling and denoising is set. For viewport, I usually set it to automatic so it uses optics denoising. Let's head to Cycles Preview to see how the model looks. For lighting, I use the Nishita sky texture. Now let's head to the Rigacar add-on website digicreatures.net and click on the downloadable file rigacar.zip. That takes us to the GitHub page. Here is the actual Rigacar add-on. Click on the latest version to download. Back in Blender, we follow the usual procedure to install the add-on and enable it. Rigacar expects the car model to have 9 meshes, 1 car body, 4 wheels, and 4 brakes with specific naming convention. It also expects the model to be along the y-axis. For optimal performance, let's save the blend file and give it a name. Then, under File, External Data, Unpack Resources. This creates folders with textures and other data in the blend file folder, which we are going to access later in this tutorial. Let's start working on the model. The first step is to remove parenting and delete empties. Let's select the empty. Select all the children of that empty and press Alt-P to bring up Clear Parent menu. Now select Clear and keep transformation. Once done, delete the empty. This preserves the object's location, rotation, and scale, and we see in the viewport. Let's do the same for the other empties as well. Any text should be converted to mesh. Now is the most important step. As these models might have been designed in various softwares, we need to ensure scaling is applied before we make any changes to the meshes. And if for some reason there is negative scaling in the imported model, then normals might be flipped when scale is applied. So we need to look at face orientation and correct for normals as well. Select all the meshes by pressing A, then press Ctrl A and click on Scale to apply. Now the scale of all the meshes will be 1. Let's head to Overlays icon on the top right and in the drop-down, enable Face Orientation. Blue color indicates correct face orientation and red indicates that the normals are flipped. The usual procedure is to select the mesh, get to Edit mode, select all the vertices of the face to be flipped, and press Shift-N to recalculate normals. To make life easier, I'm using an awesome free add-on by Ivan called Asset Creation Toolset. The add-on is free, but you can purchase if you like. The add-on is available on Gumroad and the link is in the description below. Under Other Tools, we can select the mesh and click on Flip Calculate Normals and done. If certain parts of the mesh need to be recalculated, then we can get to Edit mode, select the vertices by clicking on the vertex, press L to select linked vertices, and then press Shift-N to recalculate normals and enable Inside checkbox at the bottom. Once done, we can uncheck the face orientation in the Overlays menu. Now is a good time to organize our blend file. Let's select the tire, wheel, logo and move to new collection named Wheels. Select the brake and move to new collection named Brakes. Select all the other wheel and brake meshes and move to their respective collections and hide the wheel and brake collections from the viewport for now. Now let's work on the car body meshes. Before we join the meshes, we need to ensure that the UV maps for all the meshes are under one name. Here we can observe that some of the UV maps are named UV Channel 1 and some UV Map. So let's use our Asset Creation Tool add-on to rename the UV maps. With UV ID set to 0, under Name, enter UV Car Body. Now select all the car body meshes by pressing A and click on Rename UV in the ACT add-on. Imagine how long it would take to review and rename each UV map manually, which is what I did in my previous tutorials before I came across this add-on. Next step before joining the meshes is to ensure all the modifiers have been applied to the meshes. For this, let's use the Modifier Tools add-on built into Blender that enables Apply All Modifiers with a single click instead of individually applying each modifier to each mesh. This saves a lot of time. Now select all the meshes by pressing A and under Modifier Properties, click Apply All. That's it. All modifiers have been applied to all the selected meshes. Lattice modifiers cannot be applied, but not to worry. All this work to press the magic key combo of Ctrl J to join all the meshes to one mesh. But before we join, let's make a full copy of the scene and rename it as backup. Now let's get back to our scene. Let's also apply rotation to all our meshes before we join. Now press Ctrl J to join, and there we go. Let's check the face orientations. Also, let's see the cycles render preview. With Blender 3 versions, the viewport response is simply superb. Awesome work, Blender team. Before we proceed further, let's rename our mesh as car body and hide it from the viewport. Now let's take a closer look at the tire texture. The front right tire texture seems to be mirrored as lettering is backwards. Under Properties tab, let's click on Materials and then Open Shader Editor tab on the top. Here is the node setup for the tire texture. Looks a bit complex, but it's well organized by the modeler. There are two material slots for the tire. To see what they indicate, let's select the tire and get to Edit mode. Click anywhere to deselect the selection. Now click on Front Tire Material and click on Select. This shows all the vertices assigned to this slot. Again, click anywhere on the screen to deselect. And now click on Front Tire 001 and click on Select. Now we can see that the slot Front Tire 001 is the one we need to edit to correct the lettering orientation. Let's click on the number to make this a single user copy of the material and rename this as Front Tire R. Now when we zoom in, we see the image texture node containing the tire texture image named attachment php.png. Let's click on the X to remove this image, and we can see that the part of the tire turned white. Now let's head to the textures folder we unpacked at the beginning of this tutorial and open the attachment PHP image in an image editor of your choice. Now click on Edit Image and simply flip the image horizontally and save it with a relevant file name. Back in Blender, click on Open in the Image Texture node and select the horizontally flipped image. And there we go. Perfect orientation. Let's check the other tires. For the back left tire, simply click on the Front Tire 001 slot and under Material drop-down, click on Front Tire R, which we just created. There we go. The orientation is fixed. Now back to the Rigacar add-on, we need to join the car tire, logo, and the disc as one mesh. Before we do that, let's take a look at the mesh origins and see how the meshes rotate. In order to do that, let's select all the meshes and apply rotation. Now individually the meshes are rotating fine, but let's see what happens when we join them. They are misaligned and it doesn't look good, especially if we intend to use motion blur in our animation. Now let's get back by pressing Ctrl Z. Let's first select the tire and press Shift S for cursor selection menu and choose cursor to selected at the bottom. Let's align the wheel, disc, brake, and logo to this tire's origin, which is also the 3D cursor position. When we select the wheel and zoom in, we can see that the origin of the wheel is outside the cursor, causing the misalignment and wobbling. For this, again, I'm using the ACT add-on, specifically the origin tools. Here we can individually pick the axis to move. So let's click on Geometry to Origin and move the mesh in the Y and the Z axis. Let's do the same for the rest of the meshes except the logo. For the logo, we will only move the origin but not the entire geometry, as it seems pretty much aligned. Let's repeat this procedure for all the wheels. Once done, hide the brakes from the viewport. As Rigacar expects only one mesh for each wheel, we need to join the meshes, which means we need to go through the same procedure of renaming the UV meshes and applying all modifiers before joining the wheels. The procedure is same as the car body mesh. We need to ensure that the active UV map indicated by the camera icon next to it has the common name applied to it. If not, rename it. Finally, join the meshes of each wheel to one mesh and rename accordingly. We can see that the textures are preserved. So finally, we have 4 wheels and 4 brakes. Let's move these meshes from their respective collections to the Ferrari collection and delete the wheels and brake collections. Now let's rename the meshes as per the Rigacar website recommendation. Ensure origins of wheels and car body are at origin to geometry. Leave the brake origins at the center of the wheel. By the way, I use PowerSave add-on for autosaves in Blender. This saves my blend file every minute with an autosave suffix to the original file name. Press Shift-S and move cursor to World Origin. Now select all the meshes and press Shift-A and add Armature, car deformation rig. Now select the car rig and open Rigacar tab in the N panel and click Generate. While the car rig is selected, change to pose mode, and now each widget can be selected. As the car is oriented along y-axis, on the top right in the Rigacar tab, change the wheels on y-axis from 0 to 1. Now select the blue root widget and move along y-axis, and the wheels rotate along with it to indicate that the rig is working as expected. The yellow suspension widget and the yellow dampers control the car dynamics. The green widget at the wheels control the car's braking. The red widgets are for the ground sensors. The green widget at the front of the car controls the steering. The blue widget at the back controls how much the car drifts. Let's animate this car along a path and utilize these Rigacar widgets to fine-tune the animation. Let's press Shift-A and add a curve, path, and increase the X dimension to 250 meters. While the curve is selected, let's tab into Edit mode and move the control points to model our car path. Once done, press Ctrl-A and apply all transforms on the curve. Under Properties tab on the right, click on the curve and ensure 3D is selected. Increase the resolution preview to 100 for a smooth curve. Under Curve Deform, uncheck the radius. Now let's add a mesh, plane, and change the dimensions in X and Y to 10 meters. Press Ctrl-A to apply all transforms for the plane, which eventually becomes our car path. In the Properties tab, under Modifiers, add an array modifier. Change the fit type to fit curve, and select the NURBS path as the curve. Now add a curve modifier and select the NURBS path as the curve object and leave the deform axis as x-axis. There we go. The plane follows the NURBS path. However, if you look closely, the path is jagged. Let's sort that out. Let's uncheck the viewport visibility of all modifiers using the Modifier Tools add-on. Now while the mesh is selected, tab into Edit mode. Right-click on the mesh and click on Subdivide. At the bottom on the left, change the number of cuts to 10. Tab back into Object mode and turn on all the modifiers. Now add a Displace modifier to the plane. Click on the new texture. Under Texture Properties at the bottom, under Type, choose Clouds. Back in the Modifier panel, reduce the strength from 1 to 0.02. In the 3D viewport, right-click on the car path and select Shade Smooth. To texture our road, I'm using Extreme PBR add-on. For the usual procedure, please take a look at my Simple Road tutorial. From the selection menu, I chose the Asphalt Street version and added a 4K texture to the car path. Now let's select the car rig, change from object mode to pose mode. With the main root widget selected, head to Bone Constraint Properties in the Properties tab. Under Add Bone Constraint, select Follow Path and select the NURBS path as the target. Check on Follow Curve for the car rig to align its direction to the path. Now, as we change the offset, the car moves along the path. With the frame position at frame 1 on the timeline, let's set the offset to -99. And insert a keyframe by pressing I while the mouse cursor is over the Offset tab. Change the frame end to 500. And while frame 500 is selected, set the offset to 0 and insert a keyframe. So we have keyframed the car's start and end positions, and the car moves between these two offset positions. In order to follow the car with the camera, let's first add an empty. Under Properties tab, head to Object Constraint Properties and add a Follow Path constraint and follow the same exact procedure as we did for the car's root widget. Next, let's add a camera to the scene, and with the viewport set to the desired view, press Ctrl-Alt numpad 0 to align the active camera to the view. Adjust the view further by enabling the camera to view under the View End panel, and once done, uncheck the camera to view. Now select the camera, Shift-select the empty and press Ctrl-P and set Parent to Object. Keep Transform. Let's play the animation, and now the camera follows the empty through which we can follow the car. On a side note, I use Simple Tabs add-on to organize my end panel tabs. While the car rig is selected, let's head to Rigacar tab in the end panel. In the timeline, change the interpolation mode to linear for both car rig and the empty. In the Rigacar tab, ensure that the wheels on y-axis is 1. Now click on Bake Car Steering. I use the rotation factor of 4 and keyframe tolerance of 0 and click OK. Bake Wheels Rotation. Now select the car path as the ground sensor plane for all the sensors. Let's play the animation. The car is steering properly. With motion blur during rendering, wheel rotation is not much of a problem. Let's take a look at the car suspension widget to control the body roll during turns. At frame 80, let's select the suspension widget. Open the Item tab in the End panel. Let's change the transformation to local. Here, keyframe the initial value of 0. Now move to frame 160 and here also keyframe the value of 0. Now let's move to frame 120. Press G and X to move the suspension widget on the local x-axis to emulate the car body roll during a turn. Once the value is finalized, press I to keyframe. Let's repeat this procedure for the next turn as well. Play the animation to see the body roll. Now let's take a look at the drift widget. Let's head to frame 90 where the drift starts. While the drift widget is selected in the pose mode, press R to rotate the widget that in turn rotates the car about the front axle. Let's keyframe initial rotation value 0. Move to frame 120 and input Z value of minus 30 degrees and keyframe the rotation. Move to frame 150 and bring back the rotation values to 0 and keyframe. Now play the animation from the beginning. I know the drift looks pretty bland, but we will make it interesting in the coming tutorials. Let's take a look at the animation one more time in the Look Dev mode. Let's make the camera animation a little more interesting by adding a Quake racing camera from the Quake Motion Camera add-on. This add-on requires a tutorial by itself, but I just wanted to share with you the capabilities of this awesome add-on. We can tweak the camera shake parameters in the graph editor to suit our needs. Let's play the animation and see how it adds a bit of realism to the animation. There we go. Now let's work on adjusting the car lane. This can be done by selecting the car path mesh, and while the local transformation is selected, press G and Y to move. There we go. Let's prepare for a sample render using normal camera. Let's head to render properties and adjust the settings accordingly. Here are my settings. Let's also add motion blur to the scene, which really sells the animation. As I'm using a GPU, I prefer the tiling size of 512. Let's ensure the camera is parented to the empty and then render image. That's a beautiful motion shot. Now let's add a bit of camera animation. At frame 20, while the camera is selected, let's add a keyframe for camera's location and rotation. At frame 122, while the camera to view is enabled, under View tab in the N panel, rotate the camera view to suit our animation. Now keyframe the camera's location and rotation. That's the sample animation we were looking for. Let's get to output properties. Select the frame range we are interested in and also select the output folder. Back in Render Properties, under Performance, enable persistent data for faster animation renders. Click on Render Animation. Once we have the rendered image sequence, the sequence can be imported into a video editor of your choice and export as video. Here I'm using the free version of DaVinci Resolve. You can also use Blender's video sequence editor to achieve the same as discussed in my previous tutorials. The character sitting in the driver's seat at the intro of this tutorial is from Mixamo, which I'll discuss in my upcoming tutorials. Thank you for watching. I hope you liked this video, and if you do, please consider subscribing to my YouTube channel Blender Cinematic.